here just a moment. All right, I got 10 if you want to scroll down to 11. All right, I got 11. And section 4, I don't know why this is here. I'm gonna grab a snip of it anyway. I don't think we need it. All right, let me grab that. All right, is that everything? I don't think everything.
That's all, I think.
Okay, let me go ahead and share my screen now. And
Okay.
we'll take a look at these questions. So your screen. Yes, I would like to share. All right, there we go. You should be seeing my screen here. Make sure you are before
I
we get
am.
much further into this. We'll go into, oh boy. So it looks like they didn't give you. Would you expect the probability of part B to be higher than that of part A? Okay, so there are some rules here. So when the sample size increases.
Oh, did you see the first part? Suppose X has a distribution with the mean.
Yeah, I missed that. I
You
missed
want
that.
that?
It would help, yeah, if you want to reshare. Might be able to do it without it, but
Can you see it?
I'm not seeing your screen. No. Yep, there it is.
No?
Oh,
So
that
it's just,
yeah, there it is. That's all that I needed. Yes.
okay.
Okay, that actually doesn't help a ton, but it's probably good to have. All right, let me go ahead and share my screen. Okay, there we go. Not yet. 1, 2, 3, go. Okay, there it is. So the idea here is would you expect the probability of part B to be higher than that of part A? Kind of unfair because you don't have those parts anymore, but I think we can still do it. So the question 1 says the standard deviation of part B is smaller because of the larger sample size. Okay, so there's some relationships. As n goes up, standard deviation does go down.
Okay.
And that does appear to be true. So that's looking pretty good here. Because the sample size is large in part B, we expect a greater proportion of data to fall within one standard deviation of mu x. So this one is actually for sure false. We can talk about why in a moment. It's related to this. Because
I
the
think
sample
I picked
size
that one.
because the sample size is larger in part B, we can calculate a more precise probability. That's just a weird answer altogether. Nothing in there. Okay, the average in part B is greater because the larger sample size. So that again was also so this one is the only possible reasonable answer there. It comes from over here on this relationship that as the sample size increases, the standard deviation goes down. And the reverse is too, as the sample size goes down, the standard deviation increases.
Okay.
And there's a bunch of these relationships that you may want to know to shorten your timetable on the tests and quizzes and stuff.
Okay.
But that's obviously up to you if you want to do that. All right, so that takes care of that one. Let's go to next question here. Section 2. The main thing that you want to take away from these are the numbers, mu and standard deviation. Then the rest of this is comes from that. Like the words are nice, but we don't really need them. What is the probability that 20 cars chosen at random will have a mean load weight X bar of less than 74.5? So it's the probability that X bar is less than 74.5. Your Z is X bar minus mu over sigma divided by the square root of n. 74.5 minus 75. So this is where I'm getting the numbers. X bar is this number here. Mu is this number here. Sigma is 0.8. Square root of 20. So this is when it says 20 cars, that's n equals 20.
Okay.
So this is some sort of a number that you want to be able to calculate. I think you said you're allowed to use like some sort of a calculator on this.
Yes.
Okay, so let me calculate that for you, but always good to kind of work the calculations with me just in case you got any questions on that. 0.8. All right, so wow, that's really small. Okay. So the answer here is that Z ends up being minus 2.80. And what that means in relation to a normal curve, you've probably been seeing these in class or in the videos, is that's minus 2.8 is there. And we want all the area over here. Okay, all the area over there. So to do that, you guys were given a table or a lookup. Well, how have you guys been doing that
Yeah,
in
they
the
gave
video?
us a table.
Okay, so let me grab a table, unless
Okay.
you've got the one that you want to send over, just to show
Um,
you how to work it.
I would have to go get it out of the notes. Do you want
That's
me to get
okay.
it?
No, not necessary. I'm gonna grab one. I mean, they're all about the same, so just so you know how they work. So here is here's the top half of a normal distribution table. And it looks pretty overwhelming, but what you care about is the Z value along the left. So you go find your Z value minus 2.8 and then double zero. So that's minus 2.80. So we're looking at this number where the crosshairs are right there. So 0.00256, which is that one there.
Okay. I think I picked the other one. I don't know how I got confused. I put I think I put 0.26. That one. I don't know.
That is a common mistake. Any questions on how to do the Z calculation or anything like that?
No. Mm-mm.
Okay. All right. I like that you get two attempts. That's always nice. All right, here we go. So here's section 3. A lot of words again. The thing you want to take away are this number, and then whatever the question is asking you. So again, it's asking for the probability that X is less than 3,500. So again, it's a Z. X minus mu over sigma divided by the square root of n. Your X is 3,500. Your mu is 7,500. That's from up here at the top. And your sigma is 1750. That comes from up here. And then square root of n, it says a single test. That means that n equals
1.
1. Yeah.
Okay.
And not a bad assumption. Like if you're ever unsure, just make it 1. Might work out somewhat reasonably.
Okay.
All right, so we're going to do this calculation here. 3,500 minus 7,500 over 1,750 ends up being minus 2.29. So just like the previous problem, we're going to draw a normal distribution again. Minus 2.29 is over here somewhere. And we're going to calculate the area in the curve, just like we did in the previous problem. So we're going to go back to that table. I'm going to grab it and snip it in down here. Grab this table. So we got to find minus 2.29. It's not in this part of the table. So let me go grab the rest of the table. Okay, so this will be a little bit clearer. So minus 2.2 is right there. 2.29 is there. So we're finding the intersection of those. Sometimes what you do is you just go all the way over and all the way down until you hit. And you can see that it's 0.01101. Let's go see if that's one of the answers.
Yep.
There it is. Not too bad
What I
when you
picked.
know what to do, of course.
Yeah, I need to stick you in my back pocket.
Yeah. Oh boy. Teacher didn't help you out here, so we may not be able to do this one. Repeat part B for the 3 tests taken a week apart. We've got some issues here because the reason we have issues here is that we don't have part B. We just have, I guess, part A. Yeah,
Stupid.
I don't, they missed some of the important information. Let's see if we can decode this. Let's look at the answer here, 0.011. Oh boy, I couldn't even tell you how to guess here. This one seems wrong because of that thing there. This is double, so I'm gonna say that one's out. I guess if you're asking me, I would go with this one. Do you remember what you guessed the previous time?
I would have to look.
Why don't you, if you can, that would help, just so we don't guess the same one.
Okay.
But there's no way for me to help you on this because I don't
That's
know
so
what part B was.
stupid that they do that.
You might mention that to your instructor. You say, hey, I was, working on question 10. It said part B. I didn't get part B in the retake.
Okay. On the test, like they don't even show you like what you missed or anything. They don't go over it or anything. So I have no clue which ones I missed.
Yeah, it's always frustrating. It's because they're trying to keep you from posting these to the internet so that people don't see them for future classes, things like that. Compare your answers to part A, B, and C. What would you draw as a doctor or a nurse? It looks pretty likely that I don't know if they're like, what was the beginning part of this? What was the whole thing about? Blood
I
cell
think I
count.
picked the one that said all of the above.
So the idea is like if 3 tests indicate that they're less than 3,500, they probably have leukemia.
I have mine like that in here.
That's what I would think, right?
That seems reasonable. I think that's maybe the whole like overarching, what do we want you to remember from
Okay.
this?
All right, well, I'll just pick that and we'll see what happens. So if I get 2 wrong, then we know it's those last 2 probably.
Most likely, yeah.
Because we don't
most
have
likely.
anything to go with it,
Yeah.
Okay, here I go. I'm submitting it. 92.
Sounds like did a little better this time on the retake.
Yes. It was a 60 something.
All right, good.
Okay, so I don't want to confuse myself. I know it's short, but I understand since you showed me, so I'm good. But I want tomorrow, how are we gonna do the R?
Could you share your screen again? I'd like to kind of do what you guys are working on. If it's
The R?
also, yeah, the other options, you could also provide me access if you're comfortable doing that. But at a minimum, I need to see your screen to see what you guys are doing so I can help, hopefully.
Well, I can open up the quiz. That's all I can do.
Oh, is the R a quiz or is it
Yeah.
okay, well, that's all right. We can navigate that.
Really, you want to do it now?
Is it timed?
Yeah.
No, we should not do it.
Let me see how many attempts we have though. We might have like 2 or 3 attempts.
If you have 2 attempts, that could be okay. I mean, they always say, they always say 120 minutes, but they're not always timed. So just please be sure that it actually is before we do it.
Let me see how many. It says quantiles and measuring normal distribution is the R2 lab.
Okay.
Let's see how many attempts.
It's also possible you don't need
2
R.
attempts.
Yeah,
Should we try?
it's up to you. We have time now if you would like.
Okay. All right, I'll share my
I
screen.
I think there's minimal risk if you want to do it now.
Okay. I just need to share my screen, correct?
Yes.
Can you see it?
Not yet.
No? Yes?
Yes, I can see it now. Yep.
Okay.
Yeah. This says no time limit, so you're okay. You can start it.
Okay, so I'm starting it.
Yep.
But I can't access the R myself.
That's okay. We'll
Because I'm
see.
on Razzie's computer and I don't have it installed in here.
That's okay. We'll see what we need here. Let me do this. All right. Scroll down, please.
Okay, hold on. Let me, I gotta scoot over 1 second. We're at work and they're eating dinner. Okay, 1 second. Okay, so you got that one?
Yep. Go ahead and scroll down. Right there's good. Let me grab that part. So I grab the graph. All right, go down. Yeah, let me grab those answers. I didn't grab the answer. Now I got them. So the first one doesn't have anything to do with with R, so we're okay so far. Keep
Yes,
going.
I can't hear.
Number 2, yes, right there's good. All right, so this one does require the data, so we're gonna have to figure that out here in a moment. All right, scroll down, please. All right, let me grab this question.
Okay, I don't believe that that's true, because I can never believe you, so I can't.
All right, you can scroll down to the next question.
Believe you, because you were lying when you said that.
All right, that's good right there. Let me grab that part.
You know that.
All right, you can scroll down a bit more, please. Yeah, all the way up to quick calculation right there. Up, let's scroll up just a tiny bit. There you go. All right, that will work. Let me grab the snip. All right, this one does not require R. So we'll scroll down. Yeah, you can scroll down here. 5. All right, this also does not require R, but I mean, they're trying to teach you R as part of this, but that's okay. So we do need the data set. So scroll up to the top, I guess, if you don't mind. So see where keep going. Yeah. Today we'll be working with the penguin measurements. You get the following R commands: install package Palmer penguins. Okay, so actually we can do this. Let me see if I can. That looks like a generic package. Yeah, so let me try installing R while we're here. I've got it on my old computer, but I haven't put it on this machine yet. But it
Okay.
shouldn't take that long to download. And then maybe we can show you some of this. Download and install R. That sounds good. Download R for Windows. Install R for the first time. Boy, they sure don't make this as clean as it should be. Downloads, save. Very good. All right, so there it is. English. I'm just installing it on my side. Standard defaults. That looks good. Shortcut sounds good. That sounds good. Okay. Then we need to get our studio. That's also good to have. All right. I got everything I think I need from your screen. You can stop sharing if you'd like. I'm going to need just another moment to install this other piece of software.
I hope my daughter marries somebody smart like you.
Well, some of us smart are still. Seems that the best success is not the well, that's a different topic, a different day. Gosh, that dating world, I mean, it's a math problem in and of itself. You think opposites attract, but no. All right, I'm just installing our studio, and then we should be able to do this. Hopefully. All right, finish. Let's see if it'll launch. It'll launch. Come on, launch. Where is it? All right, let me share my screen now. Right, here we go. So here is here's my screen. Hopefully you're seeing that.
I
And
am.
then the first thing it says here is to install package. So I'm going to try that here. Install dot packages. And then Palmer penguins, like that in quotes. I'm just grabbing the same test. Would you like to use is not writable? Sure. Yes, I don't know what I'm doing, but there we go. That sounds good. So it's installing some package, okay? And
Okay.
then that appeared to be done. So now I'm gonna grab the second command. Actually, I'm gonna share my full screen. Maybe that will make all the difference here. So I'm just following the things on the right here. I'm not doing anything special.
Okay.
See how far we can get. Package equals Palmer penguins, like that.
Okay.
Seemed like it worked. Okay. All right. So there's probably a way to create a histogram in R for the data set. What I don't remember right off the top of my head is
Is it
where
hist, HIST, and then
probably you have to sort of grab the R GUI. Though. This isn't what I want though. Let me, I don't feel like I meant to open up our studio. Use your machines. Okay, so I didn't, we might have to redo some of that.
Okay, thanks.
There it is. Man, sure, why not? Okay, sorry, let's restart here. Yeah. Yeah, I started with the wrong thing.
it's okay.
All right, so I'm gonna repeat here. All right, so install packages. I don't think I'll remember that command. Okay. Yeah, this looks better. Packages. And then Palmer penguins. Okay, so it seems like that worked data. There's a bunch of error messages, but we're just gonna ignore those. All right, so there it is. So the data did get uploaded here. Let me just make sure you are seeing what I think you're seeing. Yeah, there you go. Okay. So what I'm seeing here is that we've got some sort of a data set, and there's the data set right there. So there's your data set. Is that kind of okay?
Yes.
All right, so it looks like we want a flipper length histogram. So we want some sort of like a histogram of this flipper length.
Okay.
And you're right, there's some sort of like histogram function like thing for that. So if you're okay, I'm just gonna quickly look up some of these commands because I don't know them.
Yeah, I know, that's fine.
Histogram, although we don't need it for the first one, but 'cause I think it has it right there. It says, what's the following histogram? I comment on the use of a single box plot for this data. So when I look at the first, do you have question one up in front of you? On
Yeah.
so it's just saying which of the look at the following histogram and comment on the use of a single box plot for the data. It's a histogram, not a box plot. That's an error. So I'm oh no. It's saying here's the histogram. What would a box plot? Well, the box plot would not show the bimodal structure of the data. Right now, bimodal, that means this is kind of a mode and this is kind of a mode. Now, the reason it's bimodal is I'm guessing there's two genders, and actually like human heights are bimodal. There's, female and male. Male tend to be taller than females as a general statement. So the box plot itself would never show this bimodal structure. So I believe that to be the correct answer.
A,
Yes.
because it's male, female.
Yes.
Okay.
So it wouldn't show, the box plots don't show that at all.
Okay.
Okay, now what it looks like in question 2, it's asking you to create a box plot of penguin mass by species, okay? Which that is kind of a more challenging thing for us to do in R, but we can try to do it here. So let's I'm gonna have to do just some quick searching to see how to do this, but shouldn't be too hard to figure out how to create a box plot in R here. Get all the right commands. If you're okay with that, I'm just gonna spend a little time looking
Of
up
course.
how to do that. Box. I don't use R for like statistical analysis, but it's a fantastic tool. I just don't have a reason to use it. But that's what that's what they have you do here. So list of frames. All right. So what we're trying to do in the data set is we want to basically grab like species, whatever that species is called, and then just the masses of those. Like we want to create what's called a data frame for those. And that's
Okay.
what I'm kind of looking up how to do here, which I'm not, do you have anything, any other notes from class, like some examples, anything like that that you could send over? Like usually they upload like a, getting started in R type of thing.
He had a video, but the video didn't show this part. I didn't see this part.
Okay. All right. Box plot. X is the formula and data equals notes
Like it didn't
frame.
tell me like how do you, put in the body, if you want the body mass species by species, like the command for it, like he doesn't tell you that.
Okay.
I'm
Sometimes
assuming
what they give you like a similar one and they're like, okay, here, here's how to do it. And here's the other example. But I get it. Right. R
like the
data frame.
histogram, they went over that one. But when I tried to run it, I couldn't get it to run. I don't know what I was doing wrong, but
Yeah, I'm gonna get them all out. Okay, okay.
Frame.
Thank you. You know what else he broke these cents? Oh, good. Well, it's known as a bacon burger and creamy.
Use single brackets access columns of data from the data frame.
So I made a better one. I had to feed for her deal for $3.99. Long loss makers of powerful paper manufacturers for 89 years believes in continuous improvement like rounded corners that make them clean with an array of active ingredients inside to relieve your paper. So long loss, it's good medicine.
even the small ones are gone too, or just the big ones? The big ones are gone. That's really strange. You think they're like putting juice and taking off with them?
So you look daily bonus with
Portia? But Portia doesn't look like she drinks anything out of it. He's blaming on Elena and says Elena doesn't like those cups. Maybe we should put their names on it. Even the ones that.
But it's gonna wear off.
Yeah, but at least you'll see which ones are.
I mean, I'm gonna put it right here for now.
And see how much you can save.
Yeah, I'll put Chet over here. Give her later.
Because I was gonna put it there, but I thought she could walk, but she can't.
Then you should have her scoot over.
Which penguins species equals
So now we got 1, 2, 3, 4.
But she should be able to roll the chair and then from the chair sit in the, well, she's walking 50 feet.
You know?
Oh, I know.
Okay, I think I've got something up here that might be useful whenever you're ready to look with me. You could let me know if you're still there. I don't know if
Oh,
you're
yeah,
muted or
I'm
not.
here.
Okay, sorry, I didn't know. Just want to make sure.
Oh, no,
All right,
no.
so don't worry about the commands, but there's three box plots. One is for Gen 2, second is for Adelie, third is for Chinstrap. I don't know anything about those, but now we can look at the question at least and answer it. So the first thing says Gen 2 penguins, and I'm looking at that question there. Gen 2 penguins are the heaviest of the three species. So the way to answer that is like, is this histogram like higher up than all the others? I would say yes, it is. So the first one is a yes.
Okay. Yazzie, can you turn that TV off on me? I can't focus. And somebody spilled all that soda. I'll clean it up, don't worry.
All right, second box here, it says typical body masses of Adelie and Chipstap are similar. So are these similar, these two on the right? Yeah, they're pretty similar, but this one in the middle, which I said was, what did I say that one was? Adelie is a little bit more variable. That is true because it's got a little bit taller top and bottom, a little bit wider in here. But that second box is true.
Okay.
Okay, the next one says it's rare to see Adelie penguins heavier than 3.5 kilograms. That's 3,500 grams. That's right there. I'm gonna wear my mouth up. You can't see. Yeah, you can't see that mouse. That's not rare because over 50% are above that. So we would not check that. The middle 50% of chin strap penguins is roughly 3,500 to 4,000. Yeah, that's about 3,500 to 4,000 that's here. So that fourth one you will check. And the last one is variation number 2. So did you get all those down? Which ones to check?
Yes, the first one, second one, fourth one, and not the last
That's
one,
right.
right?
That's right. Okay, so question 3 is to do a middle 90% calculation.
Okay.
The middle 90%. All right, let me do a quick look on this.
If I were to go on YouTube, would I'm sure there's something on there that can explain to me how to work with R, right?
You're looking for like a getting started.
Yeah.
But take this in like I mean this in the kindest way possible. If you're not a tech person or you're not tech savvy, you're going to be extremely
No,
frustrated.
I'm not.
It's worse than a phone. Like it's not it's not that easy to just, get up and running.
Okay. Well, the good thing is it's not on my test. It's just homework, whatever this
Yeah.
is. He's considering this homework.
Good, good.
So, and I think he drops, I think there's 4 of them and he drops 2 out of the 4.
Right. Well, we're gonna make good progress in this one because it's pretty easy so far. Like it's
Yeah.
not a big deal to be able to do this. Yeah, quantile.
So it happens when you get old, Matt.
It's not good. Don't get old,
I'm
right?
an
That's
old lady.
that's
Yeah.
we all struggle. It's default form. Well, I don't want the default form. I want to know. Okay, quantile in R. So basically what I'm doing on the other screen is I'm looking up the commands, like figuring out how to use them in real time,
Okay.
which is good for you. It's taking longer than I would like, but it's just because I don't use this every day. So not,
No, you're fine.
but na.rm equals true. I don't know which ones. Right, that's what we want. Okay, so let's try this. Quantile. Which one were we asking about? The Adelaide? Yeah, the Adelaide.
Yeah, it's masses for the Adelaide.
na.rm equals t.
Done?
See if this works.
Yeah, that was cool.
All right, there it is. There's the middle 90%, 3,000, about
Yeah, I'm gonna
4,500. Let's see if that's one of the answers.
3,000 to 4488.
That's close enough. Yeah.
That one?
Yep.
Okay, that's the one.
Okay, so the last two have nothing to do with R. They're totally unrelated.
Okay.
So yeah, we can finish these two up in today's lesson. So we got go back to the other screen for these. I'll share that shortly. All right. Let me share. All right. If you're seeing my screen, should be this a quick calculation. You have that in front of you.
Yeah.
Okay. All right. So the way to do this calculation is you're going to do two Z calculations.
Okay.
37 minus 39.8 over 2.05. That's Z1. Z2 is going to be 43 minus 39.8 over 2.05. It says a randomly selected, so that's the n equals 1
Okay, but where'd you get the 37 from?
right here, 37 and 43.
Oh, wait, what am I looking at? Hold on. Okay, okay. I'm
All
looking
right, so
at
we're gonna calculate both of
stuff
these.
above it. Okay. So it has nothing to do with.
No.
Oh, how confusing. Okay.
They want you to use R to do it, and R can do this. R is great, but for a first-time student, probably better just to do it this way. So this is
Okay.
minus 1.37. Second one here is, all right, 1.56. So we're finding the area in the normal curve between minus 1.37 and 1.56. So without getting into the details of how to do that, I'm just going to do the calculation if you're okay with that. That's what it is. 1.56 minus.
So do we subtract those two?
You're going to subtract the two areas, and it ends up being 0.8553 or 0.855.
Yep, that's one of the answers. Okay.
All right, the last one there. So the 90th percentile. So the idea here is that you're trying to figure out if not, where is 90? If this is 90% of the area, what's the Z value? There's
Okay.
what's called an inverse norm, a lookup. And what you find out is that this is 1.28.
Okay,
And then you, this Z X bar minus mu over sigma, when you solve for X, and this might
Mhm.
be a given formula, it ends up being mu plus sigma times Z. Your mu is 39.8 plus 2.05 times the 1.28, that's the Z value.
Okay,
And you'll calculate that to be 43.859.
mm, it's not on there, so is it 43.2?
Let me double check. Surprised that 39.8, 2.05, 90th percentile. Huh. I'm just looking over this. It's just yeah, it should have worked out nicer. 39.8. 39.8 is the mean. You're adding that 1.28. I guess that's right. Yeah, I guess just go with this one.
Okay.
It seems to be the most,
So 43.2, that one?
yeah, yeah.
All right,
If you end up redoing it, go with the other one.
which one?
42.4.
42.
42. Yeah, it's definitely up around there.
40, okay, I'm gonna turn it in real quick.
Okay.
Happens.
All right. So that's going to do it for us for today.